Dear students, today my class is for 9th class Maths, chapter 5. Chapter 5 Introduction to Euclid's Geometry, exercise 5.1. 9th class Maths, chapter 5 Introduction to Euclid's Geometry, exercise 5.1. Before going to this class, please subscribe King Classroom for Maths and computer online classes. Okay, now coming to the class. So, 9th class Maths and computer online classes, 9th class Maths chapter 5 Introduction to Euclid's Geometry, exercise 5.1. So, geometry mainly used in measure the land, river, and ancient pyramids also, and the ancient pyramids also designed with geometry. So, geometry is not a small thing. It born around 2000 years back or something, 5000 years back. Egypt pyramids also designed with geometry. Okay, now in exercise 5.1, first problem: which of the following statements are true and which are false? Give reason for your answers. Now first one, this is A, B, C. AB, PQ and XY is the points. Figure 5.9. Solution: only one line can pass through a single point. False, because we can draw infinite number of lines through a given point as shown below. Even one line only one line cannot pass, because we can draw infinite lines. So here the infinite lines you can pass through a single point. Okay, there are there are an infinite number of lines which pass through two distinct points. False, according to axiom 5.1, given any two distinct points, there is a unique line that passes through them. Only one line can pass through them, 2 points. Okay, in between 2 points only one line. We can draw only one line passing through distinct point as shown below. This is the example PQ. Okay, 2 points, in between 2 points only one line we can draw. Okay, third point: a terminated line can be produced indefinitely on both sides. True, according to the postulate 2. A terminated line can be produced indefinitely. We know that a straight line can be produced on both sides as shown using the dotted lines shown below. Okay, infinite. Okay, P and Q, dotted lines, straight lines, dotted lines shown below. Okay, indefinitely both on lines. True, according to the postulate, a terminated line can be produced indefinitely. Okay, fourth problem: if two circles are given, then their radii are equal. True, according to the postulate 3, a circle can draw with any center of any radius. Okay, any center with any radius. We know that circles are equal. Already the assumption is circles are equal, which means the circles are congruent. Okay, circles can coinciding with each other. Congruent means coinciding with each other. This means the circumference of are equal, and so the radii of two circles are equal. Okay, fifth, in figure 5.9, if AB equal to PQ and PQ equal to XY, then AB equal to XY. True, the line segments whose corresponding lengths are equal to one another. Okay, AB equal to PQ, PQ equals to XY, then AB equals to XY. Okay, by transitivity law, we know that if A equals to B and B equals to C, then A equals to C. Here, since AB equals to PQ and PQ is equal to XY, then therefore AB equals to XY according to this law, transitivity law. Okay, let us consider AB is equals to 5 centimeters, then PQ will be 5 centimeters, but PQ is equals to XY, so XY will also be 5 centimeters. Thus, AB equals to PQ, PQ is equals to XY, which is also implies AB equals to, which also implies AB is equals to XY. Okay, second problem. Give a definition for each of the following terms. This is very important. Huh? Are there other terms that need to be defined first? What are they and how might you define them? First, parallel lines, perpendicular lines, line segment, radius of circle and square. Solution. We have to define ray, straight line and point. First we have to know about ray, first straight line and point. Ray. Ray, a part of a line which starts at a point here A and goes off a particular direction to infinity position, possibly through a second point B in this case. Okay, ray, particular point A point to B point, there the ray will be going through infinity. Okay, that is called ray. Straight line, the basic concept about the line is that should be straight. And it can be extended infinitely on both directions. Ray will be passing one direction, straight line will be passing both directions. Here arrow marks given both, here only A to B, here B to A also, A to B also, the straight line will be going. Okay. Point, a small dot made by sharp pencil on a sheet of a paper gives an idea about the point. Point is nothing but a small dot. Okay, a point has no dimension, that is length, breadth and height. It has only a position. The point has no dimensions, length, there is no length, breadth and height. It has only one position. One position means one particular area. The point should be denoted in a particular area. Perpendicular distance, shortest distance between a point and a line is known as perpendicular distance. Shortest distance between a point or a line is known as perpendicular. First one, parallel lines. What is parallel lines? If the perpendicular distance between two lines is always constant, then these are called parallel. Perpendicular lines between two always constants. Distance will be always constants, like this one. Then these are called parallel. If the lengths of common perpendicular at different points on the lines are the same, then these lines are called parallel. Different lines, different position on perpendicular lines have distance is common and lines are in the same, then these lines are called parallel. In other words, the lines which never intersect each other are called parallel. That means lines which never intersect, that means collides with each other, that is called parallel. These are the parallel line, PQ and RS. PQ directions both side and RS is the both side. Perpendicular, this is called perpendicular. Perpendicular lines. If the angle between two lines R is equal to 90 degrees, then these lines are perpendicular to each other. The angle between two lines, these two, angle between two lines is equals to 90 degrees. This is called BC is the perpendicular line. Okay, CD, AB, AB, CD. Okay, this 90 degrees is the perpendicular line. Line segment. A terminated line is called a line segment. It has two end points, AB and AB in the case. Terminated lines, end points, that is A and B. This is called line segment. It will not go out of the A and B. Okay. Radius of the circle. The distance from the center of any point on the circle is given, is called the radius of the circle. This is radius. Okay. O to circle arrow. is a radius. Square. A square is a rectangular quadrilateral, which means that it has four equal sides and four right angles. Okay, these four equal sides and four right angles are square. Third point, third question, third problem. Consider two postulates given below. Given any two distinct points A and B, there exists a third point C which is in between A and B. There exist at least three points that are not on the same line. Do these postulates contain any undefined terms? Are these postulates consistent? Do they follow the Euclid's postulates example? Explain. Do they follow from Euclid's postulate? Explain. Solution. We will use Euclid's exams here to check these postulates. Yes, these postulates contain undefined terms like point and line. These two statements are consistent and they talk about two different situations meaning different things. These statements do not follow Euclid's postulates, but one of the exams about given any two points, a unique line that pass through them is followed. First one is okay, second one is not. Fourth problem. If a point C lies between two points A and B such that AC is equals to BC, then prove that AC is equals to half AB. Explain by drawing the figure. Solution. According to Euclid's exams, we know that when equal are added to equals, then wholes are equal. So the line is ACB. One line A point, C point and B point. Given AC is equals to BC. Already given AC is equals to BC. Adding AC on both sides, we get AC plus AC is equals to BC plus AC. BC plus AC coincides with AB. Okay? BC plus AC coincides with AB. AB to coincides. Okay? AC plus AC is equal to 2AC plus BC plus AC is equals to already given, that is BC plus AC is equals to AB. So BC plus AC is equal to AB. So AC is equals to, here multiplying to in RHS goes to half divide. So half AB. Okay, and proof. Fifth problem. In question 4, point C is called midpoint of the line AB. Prove that every line segment has one and only one midpoint. Solution. We know that the things which coincide with one another are equal to one another. Let us consider that line segment AB has two midpoints C and D, as shown in the figure below. AC, DB. Okay. Let's assume C is to be a midpoint of AB. First assume C is the midpoint of AB. Then AC is equals to this. AC is equals to BC or CB. Okay. Adding AC on both sides, we get AC plus AC is equals to BC plus AC. That is equal to AC plus BC plus AC is equal to, and coincides to AB. So 2AC is equal to AB. AC is equal to half AB. First one proof. Let us consider B, a point D lying lying on AB. Let's assume D is the another midpoint of AB. So therefore AD is equals to BD. So adding both sides, adding equal lengths AD on both sides, we get AD plus AD is equals to BD plus AD. BD plus AD coincides to AB. So 2AD is equals to AB. AD is equals to half AB. AD is equals to half AB. Second point. From equation 1 and 2, we can conclude that AC is equals to AD. Here AC is equals to here AD. C has two coincides with D for AC to be equals to AD. According to Euclid's exam 4, things which coincides with one another are equal to one another. Thus, a line segment has only one midpoint. Okay, AC equals to AB. Okay, sixth point. In figure 5.1, this figure, if AC is equals to BD, then prove that AB is equal to CD. AB is equals to CD. Solution. According to Euclid's exams, we know that when equals are subtracted from equals, the remainders are equals. Equals are subtracted from equals, the remainders are equals. Listen carefully. Okay, understood. Given AC is equals to BD. Given already AC is equals to BD. So answer the line ABCD. We can draw a line ABCD like that. Hence AB plus BC is equals to BC plus CD. Okay. Since B lies between AC, B lies between AC, and C lies between BD. Okay. Subtracting BC from both sides. AB plus BC minus BC is equal to BC. A plus CD is equal to minus BC. So BC cancel, BC cancel. AB is equal to CD. Okay. Given AB is equals to CD. We proved that AB is equals to CD. Seventh problem, last problem, I think. Why is exam 5 in the list of Euclid's exams? Consider an universal truth. Note that the question not about the fifth postulate. Solution. Exam 5 of Euclid's exams states that the whole is greater than a part. Greater than the part. Whole is always greater than the part. Okay. That means in a ball, in anything, one part is greater than the whole. Whole is greater than one part. This exam is known as universal truth because it holds true in any field of mathematics and in other disciplinaries of science as well. Let us consider a line segment AB marked 2 points PQ. AB is a whole part. It is divided into 3 parts: AP, PQ, and QB. So AB is equals to AP plus PQ plus QB. Thus we see that AB greater than AP, AB greater than PQ, AB greater than QB. Hence AB is whole is greater than its parts, that is AP, PQ and QB. Let's take some practical facts to understand this. Hyderabad is a part of Telangana, which means that Telangana is larger than Hyderabad. That is Telangana greater than Hyderabad. India is part of the world, which concludes that the world is larger than India. And here the world is a whole, whereas India is a part of it. Another example. Telangana is part of India, which means the India is larger than Telangana. That is that India greater than Telangana. Therefore, it is true that whole is greater than the part, that is considered as universal truth. Thank you to watch complete video and like the video, share the video, subscribe.